This video is going to demonstrate the linked data views in VisuMap. Linked view services provide a collection of methods to display data in different ways. These views render data as glyphs, 3D shapes, curves, or bars, and etc. These views are dynamically linked to each other, so that we can interactively select any subset of the data. And these selected data will be automatically highlighted in all other views. More particularly, behind each data view is a data table with named rows and columns. When we select a part of the data in one view, those corresponding named data items will become selected, and all other views will be notified. And they will highlight those selected items in their windows. In this video we will briefly demonstrate the following major data views. We start with the value diagram view. In this view each data points will be rendered as a curve. We can open the value diagram for the whole data set by click the value diagram tool button, or open the view for a set of selected data points through the context menu. We can also open the diagram window from other data views. For example, we open the value diagram view here from the data details view. When working with the value diagram, we can easily scale the window size by scrolling the mouse wheel. With help of the Shift and Control key, we can zoom in and out, or shift the diagram through the mouse. In order to reset the diagram to auto-scaling mode, we just need to change these two window properties. Within a value diagram, we select data points by drawing a line on the window. All curves intersecting with the line will be selected. For instance, we select here those data points whose values are roughly in the middle range at the end of the time interval. We then reverse this selection through the context menu. The reversed selection contains then all data points whose values are above or below the middle range. By switching the value diagram into compact mode, we can overlay the diagram with other maps to group information more intuitively. Another mode of the value diagram is the attribute mode. In this mode we select attributes or data columns, instead of data rows in normal mode. For instance, we select here two subsets of the attributes, which correspond to two time intervals in which the attributes experience large volatilities. We then apply the PCA algorithm to examine the correlations between the data points with respect to the two time intervals. Bar view plots numeric values as horizontal or vertical bars. In order to use bar view we first need to enable the bar view context menu through the application configuration window. Then select a row or column in the data table, and open the bar view for the selected data. When we select multiple rows, the bar view will aggregate the rows to a single row through an aggregation function. The aggregation function can be configured through the property window. When using the bar view, we often need to change the baseline type to highlight particular trend in the data. The baseline type can be changed easily through the property window. We can select a subset of bars and examine their numeric details. We can also change the selecting method to line selector, so that we select bars through a straight line instead of a rectangular frame. In order to get more intuitive and compact visualization, we can change bar view to horizontal mode and compact mode. Now, we are going to visualize the ranking of the data points with respect to the last attribute, which is in this example the performance of equity stocks for a year. We first select the last column of the data table, then open the bar view and sort it. Then we select an interval of bar with small values, then we press and hold the right arrow key to move the selected intervals from the left to the right. At this moment, we can see in the main map that the corresponding data points move gradually from one region to another region. The spectrum view displays numerical values in spectrum style. In order to use spectrum view, we first need to enable the spectrum view context menu through the application configuration window, and then we can select a data point from a map, and open the spectrum window that displays the row vector behind the selected data point. We notice that the curve across the spectrum window shows the density of the spectrum lines. We can select a subset of spectrum lines, and then view their numerical details, which describe the components of the selected data point. We can also change the window into shifting mode by double-clicking the window, and then shift the spectrum with the mouse. We can stretch or shrink the spectrum directly by scrolling the mouse wheel. Now, we are going to visualize the ranking of the data points with respect to the last attribute, which is in this example the performance of equity stocks for a year. We first select the last column of the data table, and then open the spectrum view. When we now select a subset of data points, the spectrum view will automatically highlight those selected data points as red lines in the red density curve. We then open a selecting marker in the main map window, and let it move gradually from one end to another end. At this moment, we can see that in the spectrum window the red density curve moves gradually from the high-ranking right side to the low-ranking left side. Mountain View displays data points as polygons in 3D space. Each data point is rendered as a polygon with gradient color called a blade. In order to use Mountain View, we first need to enable the Mountain View context menu through the application configuration window. And then we can select some data points from a map, and open the Mountain View for the selected data. The Mountain View can be either in editing mode or scaling mode. In scaling mode, we can resize the view with the mouse wheel. And with the help of the Shift and Control key, we can also resize or shift the map in different directions. We can also rotate the view by dragging the mouse over the window. We can switch mountain view into editing mode by main menu, or by double-clicking the window. When mountain view is in editing mode, we can then select some data points, and perform further operations. For instance, we can open the selected data points in a new mountain view. The PCA view displays linear projections of selected data in 3D space. Since there is a separate video tutorial focusing on the PCA view, we just show here some basic features of the PCA view. We can open the PCA view for the complete data set through the Tool button. Within the PCA view we can rotate the data points with mouse, or resize the view with the mouse wheel. When we press and hold the Control key, we can shift the view with the mouse. We can copy the view into the main window by clicking the Capture button. We can switch the view into editing mode by double-clicking the window. In editing mode we can then annotate the data. Or open another PCA view for a subset of data set. The bar band view allows us to display multiple data points in stacked bar views. Unlike the separate bar views, all bar views in the band view share a common scaling schema, so that we can compare the values between the data points. In order to use the bar band view we first need to enable the band view context menu through the application configuration window. Then we can open the band view for selected data points through the context menu. By default, all bars are in a common color that is defined through the property window. We can change this coloring schema, so that it renders bars in the same color as corresponding glyphs in the main map. The band view can be in vertical or horizontal mode. In the horizontal mode, we can select rows of bars. Then zoom in into selected data by opening a second band view. We can switch the view into vertical mode by double-clicking the window. In this mode, we can then select bar columns and zoom in into it with a new band view. Within a band view we can sort the data based on values of a selected column or row. We can also rearrange selected columns or rows together to group similar data together. For more compact and intuitive visualization, we can switch the band view into compact mode and overlay it with other maps. The Shepherd diagram is a tool to investigate correlation between image distance and relational distance. That is, in other words, how good the proximity information of a map approximates the intrinsic similarity information between the data points. When we open the Shepherd diagram, it initially uses the first data point of the data set as the reference point, whose identifier is displayed here. With respect to this reference point the mapping quality is quite good, since the image and relation distance are strongly correlated. We can change the reference point by moving the mouse close to another data point glyph, and stay still for a short while. For instance, the mapping quality with respect to this reference point is relatively bad. With help of Shepherd diagram, we can also easily find out individual data points, which have relatively large distance distortion in the map. For instance, this data point has much large dissimilarity as indicated by the proximity on the map. Using the Shepherd diagram, we can easily select data points depending on their similarity to the reference data point. More conveniently, we can visualize the relative similarity information as following. We first change the glyph set of a map to the ordered glyph set. Then select a reference point, and click on this button. In the main map, the reference data point has the smallest size, and larger data points will have larger dissimilarities to the reference point. We can then quickly change the reference point to investigate similarity information in other regions. The 3D animation view helps us to explore data in 3D space. Since the 3D animation uses hardware acceleration, it is very fast even for large data sets. In order to use the 3D animation view, we first need to create a 3D map with one of the available mapping algorithms. For example, we create here a 3D map with CCA algorithm. We can open a 3D animation view through the main menu, or by clicking this tool button. Within the animation view window, we can resize the view with the mouse, or rotate the view by dragging the mouse. When we drag the mouse in certain direction, and quickly release the mouse button, the window will continue rotating the view in that direction. For example, here we open two 3D animation windows, and let them rotate in different directions simultaneously. The Data Details view displays the numerical or textual details of selected data. The Details view can be opened through this tool button. When the Details view is open, we can click on any data point glyph in the main map. The Details view will automatically highlight the table row for the selected data point. We can also open the Details view for a selected subset of data point through the context menu. The Data Details view has been designed to support very large tables with many thousand rows or columns. One measure to support such large table is to use smaller text font. One useful feature of the Data Details view is that it enables us to visualize the order information for any selected attribute. In order to show this feature, we first open a data set with map that uses the ordered glyph set. We then open the Data Details view. We switch the view into attribute mode by double-clicking the window. In this mode, we can select columns through the mouse. We select a column and click the column header to sort the table based on values in the selected column. Then, we click on this button to reassign glyph types to data points. In the new map, Data points with larger values for the selected attribute will be represented by larger glyphs. We can then easily repeat these steps for other attribute columns. The table editor enables users to modify a data table similarly as a spreadsheet. We open the table editor through the main menu. Then, we can change the value of any field by first clicking the field. Alternatively, we can also first click a data point in the map to make the editor highlight the corresponding row. Then edit that data point. Through the context menu we can add new columns or rows to the table. We can select a column by clicking the column head field. Then change the properties of the column through the context menu. After we finished editing, we then click on the Save button to commit the changes back into the current data set. This concludes this video. Thank you for watching.